Hey, welcome back. Hope you're doing well. Previously, we created a set of data points and initialized a linear model. We will now move on to the next step, which is, provided a set of data points, it is our goal to find the parameters of a line that will fit this data well. As you've seen before, the linear function will initially assign random weight and bias parameters to our line. Suppose it returns a line with the following parameters. Clearly, this line does not represent our data well. We need some kind of optimization algorithm that will adjust these parameters based on the total error, until we end up with a line containing suitable parameters. How do we determine these parameters? For simplicity and to get a brief understanding, let's limit our discussion to a single data point. Whatever line that we choose, the error is determined by subtracting the prediction at that point from the actual y value. The closer the prediction is to the y value, the smaller the error. The prediction, as you should already know, can be rewritten as wx1 plus b. However, since we're dealing with a single dot, an infinite amount of lines can be drawn through it. So we will remove the bias, removing that extra degree of freedom for now, and we can cancel it out by ensuring the bias term is fixed at 0. Alright, now whatever line that we're dealing with, the optimal line will have a weight that will reduce this error as close to 0 as possible. Say we're dealing with the point -3 and 3. The loss function would translate to 3 minus w times minus 3, all of that squared. Now what we're going to do is make a table and try out different values for w and see which one gives us the smallest error. A weight of -2 results in the following, which has a total error of 9. A weight of -1.5 gives us an error of 2.25. Notice how the error is analogous to the spacing between the predicted value and the actual value. The smaller the spacing, the smaller the error. A weight of 1.5 gives an error of 56.25. 2 gives an error of 81. However, if we use a line with a slope of -1, a weight of -1, clearly this perfectly fits this point. If we calculate the error between the predicted value of our linear model and the actual value, the error is 0, which makes sense as the prediction lines up well with the actual labeled value. The different errors, they vary based on which weight parameter to use for our line so that it fits our points. I've plotted different error values for different weights in Matplotlib for visualization purposes. Clearly the absolute minimum in this case corresponds to a weight of -1. Now that we know how to evaluate the error corresponding to our linear equations, the question remains, how do we train a model to know that this weight right here, that is the weight parameter that will yield the lowest error? Let's talk about that in the next lesson.